How's it, chaps, and welcome back to the Burton Builds garage. Today we are doing another teardown, a teardown of this. It's the DeWalt DCS796 brushless cordless drill. This is the 18 volt XR version. If you are from United States, then it will be the 20 volt XR. It's the same drill, just a different way of naming it. This is type 1, so it's the first iteration of this product. As we can see there, it's 18 volt XR and it's got a 13 millimeter chuck and 0 to 34,000 BPM if you're into electronic type of music. No, that's just for the hammer action. And it says here it's got 2 speeds. It is a 2-speed drill, as we can see on the top. 0 to 550 RPM for the first speed, and then 0 to 2000 RPM for the second speed. I've been really happy with this purchase. So I've owned this thing for about a year and a half now. I've used it a fair amount. I probably could have used it more, but I've used it quite a lot, mainly for drilling holes through steel like 1 millimeter, 2 millimeter, 3 millimeter, 5 millimeter steel plate. I've used it up to 12 millimeters and it works perfectly fine. Plenty of power. I'll give you an example. I was drilling through a 2 millimeter piece of plate with a 10 mil, no, it was a 12 mil drill bit. I had a pilot hole, and as the drill broke through, I was kind of drilling it arm's length, and man, this thing almost twisted my arm right off. So it is a very powerful unit. This is the mid-size unit, the 796. You also get a 996, which is slightly bigger, but this is a good bang for buck. Yeah. We are not tearing it down because it's broken, of course. It does still work. So yeah, let's get into it. To split the clamshell, we have to remove the 9 T10 Torx fasteners, and there's also 4, 1, 2, and then 3, 4 that hold the gearbox and the chuck assembly in. And then we also going to have to remove the sticker at the back. The first step to disassemble this unit is to remove the gearbox section. Now, it is kept in place by 4 T10 Torx fasteners. There's 2 on this side and there is 2 on that side. Now these things, if you've got a bigger sort of screwdriver or Torx bit than this, you might battle to get in because of this plastic ring. Now DeWalt were kind enough to design it. You can see there's a small recess, so you've just got to locate that to the screw that you are removing, and you'll be able to remove the screw fairly easily. So once we've got the gearbox assembly loose, the gearbox is also joined to the speed switch that's at the back here. So we actually need to split the clamshell to now release this gearbox completely. And just before we take the last fastener out, I'm going to carefully peel back the sticker. We also need to carefully remove the sticker at the bottom of the tool. Now that both stickers have been removed, the clamshell should just slide apart fairly easily. Oh, there we go. So there's the first look inside the DCD796. Still looking fairly clean, actually, although I haven't used it in extremely dusty environments, but I would say it's fairly good initial impressions. We can see that the gearbox didn't want to come out of the clamshell arrangement because of the speed switch over here, and that speed switch is connected into the gearbox, and that moves the planetary gear arrangements to give you your various speeds. Fairly simple to remove now. We just kind of click the switch out of place, just like that. So the first thing that I notice when we split the clamshell is the material markings, slightly different to what we are used to seeing. It's a polycarbonate / a PBT, which is a polybutylene terephthalate, and .TPE, which is a thermoplastic elastomer. Now the thermoplastic elastomer is this rubber overmolding over all of the tools that you see nowadays. The polycarbonate, I'm sure most of us are familiar with that. And the polybutylene terephthalate, I'm actually not too sure about that material. Maybe one of the viewers can chime in here and stick the some information in the comments section below. That'll be quite nice. Also, the magnetic holder that you screw onto the side of the tool. Nice to see that it's got a steel nut it's a galvanized steel nut that is molded into the plastic. And then also the speed switch on the top. There's a piece of spring steel, not just a piece of plastic that you might see in some of the cheaper tools. Now this spring steel kind of keeps the selector either forward or backwards, and it jumps over this little point. So nice to see that is spring steel. Overall, the molding looks fairly good still. Yeah, I don't know a hell of a lot about these moldings and stuff, but just always nice to see what's happening inside. Another thing that some other people have brought up in previous teardown videos is the fact that these thermoplastic elastomers, they can degrade over time, especially when you are using them with solvents on your hands. It tends to degrade the plastic. And also these little dovetail joints, nibs, whatever you want to call them, those help retain the TPE overmolding onto the actual clamshell. So there's a few of them around. There's one, two, probably a third one over there. There's a couple along this edge. Now, these things, this part specifically probably won't let go, but the parts in between, like over there, those can come loose over time. Now, we'll see some of the tool manufacturers actually making little holes, and the thermoplastic elastomer is cast through the clamshell. So you'll see little bits and pieces all over the place. But that's not the case with these tools. Although my tools, I haven't had them for too long. I probably haven't had them long enough to ever see any of the overmoldings come off. But again, maybe if some of you have seen it before and you've got photos, maybe post it somewhere or let us know in the comments. Quick overview of the inside. First thing we've got here is the light arrangement. That's together with the switch. It's a 3-position switch to control the light. We've got the battery clip or terminals for connecting the battery to everything happening inside here. Then, of course, all of the brains, the confuser that's in here, and that joins up to, it's part of the switch arrangement, and then that all goes into the brushless motor. Let's see if we can lift this whole lot out of here without damaging anything too much. Well, there's our forward and reverse plastic lever switch thing. And this is the 3-position lever that controls this little switch here. That's for the light. Yeah, seemed to come out fairly easily. Let's have a look at this side of the case. Yeah, we've pretty much got the same arrangement with the material markings over there, and also another part of spring steel for that 2-speed selector switch. And then on the other side of the drill, there is also a tool holder belt clip arrangement with a galvanized nut cast into the plastic. Also, there's a little bit of a spring steel clip over here, and this thing just holds, or I suppose supports, the 3-position switch. The part on the right hand side is the forward reverse switch lever. It's a PA6, which is a nylon, plus 30 GF, so nylon with 30% glass fiber reinforcing. Same here on the left hand side. This is the 3-position lever part of the switch for the light, and we can see also PA6 / GF30, so nylon with 30% glass fiber reinforcing. The terminals of the battery clip are actually quite thick. That's good to see. Very wide spades. There's one there and one there. And then it's got 2 internal smaller spades. Now, these outer spades would be for the main power that goes into the device. And these smaller spades likely are for the battery control unit, where the battery actually talks to the electronicals inside here. Well, at least that's what I think. On the other end of the terminal that's inside, we can see here that the joints are, what would they be, pressed, welded, soldered type joints. Now, I've previously said that I don't really enjoy these types of joints. I would like to see more of a crimped and lugged, like a bolted or screwed lugged arrangement over here. And that is the main power that goes into the board or the tool. So, yeah, if any of you know any different, I mean, maybe there's actually nothing wrong with these connections, but I just think over time with vibration and expansion and contraction, that these types of joints, these soldered or welded joints, can actually crack loose or become dry joints, whereas the screwed or the fastened joints and the crimped joints, those even though they might become loose, they can just be nipped up, but generally those wouldn't come loose. The LED looks like a fairly standard arrangement, a little bit of a plastic arrangement there with a diffuser / lens on the front. And then on the back, nice to see a nice big heatsink, aluminium heatsink, which is fastened with 2 screws. The 3-position switch for the light is also a standard plastic arrangement. The board looks fairly neat and conformally coated. And we can see here that if you want the light on between 9 and 12 o'clock, then you use that setting. If you want the light on between 6 and 12 o'clock, then you use that setting. Or if you wanted just a normal torch, then you use that setting. We can see the back of the board is also conformally coated, just a standard type board arrangement here. Nothing too spectacular. And of course, I was joking about those things. Also nice to see a plastic connector that connects the main board to the light control board. I'm guessing that if you need to replace this section, that you could buy probably just this section from DeWalt, although no guarantees. Reason being is because one of the viewers of one of our videos, I'm not too sure if it was the impact wrench or the multi-oscillating tool video, it was one of the teardown videos, he contacted me and he also said it's actually quite a pity because he does a repairing of various tools and there was a problem with one of the switches and contacted DeWalt, and DeWalt actually wanted to sell him the complete unit, so motor, switch, speed control, the whole bang shoot. And you know, to me that is absolute rubbish. I mean, that almost costs as much as a new tool, especially if nothing is wrong with your motor, or if there's only just a small something wrong with the light control board. In this case, they might make you buy the entire internal section. And you know, anybody that's capable of tearing apart tools and doing basic repairs is capable of unsoldering 3 motor joints, and the control, the Hall sensors at the back of the motor, they actually just plug in. So really, really simple to replace the speed control or the motor or the switch or parts thereof. There's absolutely no need to replace the entire thing. It's probably just a money-making scheme to get you to buy new tools when they break, like, you know, planned obsolescence, something like that. The speed control and switch is all mounted in a single plastic arrangement, and we can see here it's a PA6/GF30, so a nylon material, glass fiber reinforced 30%. That'll be this piece over here. These are likely some DeWalt part numbers, probably nothing too spectacular over there, but I would guess that when you need to order new parts that you would be quoting one of these serial numbers or pin numbers. Also, if we have a close look inside the switch, the plastics of the switch is a PA6, also glass fiber reinforced 30%, so nylon glass fiber reinforced 30%. And having a close look inside there, we can see that the switch, or the push rod of the switch, we can see it moving in there. It's got a little bit of grease on it, just to get it moving quite nice and smooth, but there is absolutely no dust control, other than the dust that will get caught in the grease, of course, but there's not much dust control. And this is what ended up happening to some of the tools that I've seen, where you get a lot of dust ingress into the tool, and that eventually wears out parts in the switch section itself, and then it generally just gets clogged up. And you know, I don't know why they can't just maybe put a little rubber bellows over there, or maybe a little wiper, a plastic O-ring, or not plastic, but a rubber O-ring or something. I mean, I guess it does cost a couple more cents, but you know, for the life of the tool, it would just really be nice to see. The speed control is this complete section over here, and we can see, as I said before, it's integrated into the switch, and you can see that it's covered in this white type of material here that is elastic. It's quite hard. It's not soft like you would think silicon is. And the reason they do this type of thing is for moisture and dust protection, and also for vibration protection. Vibration is a killer of electronics, and you can imagine how much vibration is transferred to the internals of this drill when you're drilling into, say, a concrete wall or to brick walls. Also, it does protect their design, and it makes it quite a lot more difficult for us to repair certain, say, components that might fail over time. Basically guarantees the manufacturer that you will buy a complete speed control if you want to repair the unit, or kind of forces you to buy a new one. We've got a fairly beefy brushless motor, and we can see the numbers on your N411596041718-47HB. That's just probably a shelf part number for whoever makes these motors for DeWalt. The back of the motor, where the hall sensors are connected, is plastic, nylon glass fiber reinforced 30%, and it has like a Molex or just a small white plastic connector that is glued in place. So this is definitely not going to go anywhere. We can see the 3 main motor wires are soldered onto the motor itself, and don't be fooled, these may look like crimped ends, but they are not crimped ends. They're more of like a small pigtail crimped section that guards or supports the wire coming into the joint. So again, I would have liked to see fasteners with crimped sections or ends over here. But again, I might be wrong. If any of you know any better, let us know in the comments. We can see the fan arrangement on the front of the motor is a PA66 glass fiber reinforced 33%, and it is a multi-directional fan. So whether the motor is run in forward or reverse, it still provides the same amount of cooling, which makes absolute sense in a tool like this. The gearbox on this unit is a planetary style gearbox, as we see on pretty much all cordless drills these days. And the sun gear, that's this gear on the front of the motor, it is a sintered metal part. Short of stripping the motor, which is something I don't really want to do any further, quite difficult to say what type of bushings or bearings are in the front and the back of the motor. So it's probably either got a ball bearing or an oil light bushing. Now, at a guess, this is a wild guess, but I'm going to say there's probably a ball bearing in the front of the motor and an oil light bushing at the back housing of the motor that supports the motor's shaft. If you haven't noticed already, this is a keyless chuck. It is completely metal, and there are no markings on it as to who the manufacturer is of the chuck. So I'm guessing that DeWalt don't manufacture this chuck themselves. They have somebody else externally manufacturing it, and they've just got the rights to have all of the names removed. But as an example, I had an old Ryobi drill, very old, but it had a Jacobs chuck on it, so another company making the chuck. This is quite a nice tightening unit. It's very, very solid, thick steel, and I've never had any problems with the bits coming loose, so working really well in my opinion. Having a look at the forward part of the gearbox section, that is this part over here, it is a sintered metal part. Now I'm hoping that kind of carries through to the back of the gearbox, but the clutch or this clutch setting ring here, this part is plastic, and the back over here, this part of the gearbox or the outer housing is also plastic, so don't be fooled. That is not a sintered aluminium. Looking at the gearbox from the back, there are 4 Phillips head screws we need to take loose, 1, 2, 3, 4, and I'm guessing this whole unit will actually pop out. We'll also need to unclip the speed control lever from either side of this plastic part of the gearbox. Looks like we also have to remove the 5th and the 6th screw that we can see at the back. Okay, so it's actually starting to spring apart. I'm just going to hold it in. We can fairly clearly see the 2 halves of the planetary gearboxes. There's one set of gears inside here and the second set of gears which is out of focus down here. And between the two, there is also this little steel washer type ring. The part that makes our clutch ring click, that's this part over here, is clicked by a small spring with a little piston and a half round point. So that is going to click into little indentations in the back of this ring, and that's what gives you that kind of clicking action, click, 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 as you turn the clutch. Okay, so here we can see the second reduction, part of the planetary gearbox. So looking quite nice and greasy in there. All of these look like sintered metal gears. So this is the inside of the box. We can pretty much see that this is as deep as we can go. That shaft in the middle is connected directly to the chuck. And you can see these little round, I don't know if you would call them dogs or these little round pins. Those pins form part of the locking mechanism or the keyless chuck mechanism. Those pins jam themselves into these little gaps on the right hand side here when you turn the drill from the front, or when you turn the chuck from the front, and that locks the mechanism. Now, I believe that's how it works. That's not a very technical explanation, because I'm not 100% sure, but I know it's got something to do with the pins rolling and jamming themselves into a corner and then locking the whole setup. One thing that I do want to mention, and this could be part of the sales talk, but when I bought these drills, the salesman said to me that the gearboxes are, in fact, in this specific drill, metal gearboxes, so it would be an aluminium housing. You know what? He was talking absolute rubbish. These gearboxes, the housings on them are plastic. They are very clearly plastic. Of course, they've got metal gears in them, but then again, all drills will have metal gears in them. Well, all of the reasonable drills will. So this part is probably a polycarbonate. I don't see any polycarbonate or a nylon with a lot of reinforcing in it. I don't see any material marks, but clearly plastic. And if we have a look at, now I don't really want to put this down because those little balls might fall out, but if we have a look at the front part of the gearbox, there is a metal ring that is over here. That's just a little like a speed ring that either selects the first or the second stage of the planetary gearbox, but the back is plastic. That is definitely not steel or aluminium of any kind. So definitely the oak was talking absolute rubbish. Now, these little balls, those balls form part of the clutch setup. They jam themselves in here on those little humps, and eventually when it's in the drill mode, these little balls are pressed up. This is what I believe. Those balls are pressed up and they can't ride over these little humps. So it locks the ring gear in place. And when you start setting the clutch down from 13 down to to lower numbers, all the way down to 1, it allows the ball to run up to that small hill, and it allows it to jump over the hill. And that is, I believe, how the clutch mechanism works. It might also have something to do with the hammer action, where the drill hammers itself around. Again, if anybody knows anything more, please let us know in the comments. It'll be actually great to get some deeper technical background information on this type of thing. Hope I'm going to be able to get this back together. Kind of got to get these pins nicely evenly spaced, and they've got to slot into each one of those slots. There we go. And that wasn't that difficult, just took a little bit of maneuvering. Before we put it together any further, we can check that the locking mechanism is working, and yep, I can definitely feel that it is locking. All these little planetary gears can be shuffled back into place. Okay, the next thing to go in is the sun gear. That goes back into the middle. Well, it's actually a combination. This part is the sun gear, and then the top part is the carrier for the second reduction. So it looks like we have to put this ring gear on before we actually put these planetary gears back on. I noticed the last thing we actually now have to do to get all of these internal planetary gears here to line up with this external ring gear is we've probably got to give them all a little bit of a twist or a turn so that they mesh up with that ring gear. I think that's it. She's home. Cool, all feeling nice and smooth, running freely. Those four to get back in, and let's hope the rest of the drill goes back fairly easily and it works again. Okay, so chaps, that's it. It is back together. Hopefully it is going to work. I'm pretty certain that it will. Yep, no problem there. And I suppose we can also check the light. So there's the light. So my final thoughts now that the drill is back together and working again. I would have liked to see a fully metal gearbox casing. Of course, the front is a sintered aluminium, but the center and the rear are plastic, as we saw. Also, the part where the chuck and the gearbox kind of mount onto the rest of the tool, it's only got 4 fasteners. Would have been nice to see a couple more. And then lastly, the motor wires, where the wires join onto the motor and then when the wires join onto the battery terminal, those I would have liked to see crimp style connections. But anyway, chaps, that's it. Please like, subscribe, comment, all that good stuff. I always like to hear from you guys. And maybe some of you have got a couple of these tools and have had better experiences or worse experiences. Let's share it with everybody. Okay, until next time, we'll see you. Cheers.